You're lame.
Hold on.
Hi.
It takes about 3 seconds before it actually records.
Oh, well,
You're
hi.
Everybody say hi, cross country, and Claire.
Hi.
No one loves you.
Hi, Claire. Hi, cross country.
All right. 2, linearity and symmetry. These words sound like really advanced, but they're not. Linearity. What word do you see in that?
Linear.
Linear. So linearity is a test to see if something is linear or not. So is it linear? Okay. Let's talk about like graphs of linear equations. Things that are linear look like lines, right? But if we don't have the graph, if we only have the equation, how do we know if it's linear or not?
You test it.
Maybe. We could graph it, right? But I don't want to graph every one of them. I want to just like look at the equation and know it's linear, okay? So linear equations that we learned last chapter were like y equals mx plus b. That's a slope-intercept form of a linear equation, right? So if it looks like that, if it has like y equals 2x minus 3, if it looks like that, that's a linear function, right? Or let's say it has y equals 1/3 x plus 6. That's a linear equation. What happens if it's written like 3x plus 5y equals 10?
Yes.
Is that still linear?
Yes.
Yes, the y is just not solved for, right? We would then go and solve for the y. So all of those are linear functions. So is every function linear? What happens if it's something like y equals 3x squared plus 6x? Is that linear?
You're going to.
I have no idea.
You have no idea.
I'm not
That's
that
what we're talking
smart.
about today. What happens if it's like y equals the square root of x plus 3?
I don't like that.
What happens if it's y equals 4 over x? Are those linear functions? No. Just say it. No, they're not.
No.
No, they're not. You're brilliant. No, they're not. They're not linear functions. It is only a linear function if you have an x and y and they are both to the first power. Now, none of these linear functions will actually have the ones by the powers, but you just assume that it's to the first power. So why is this one not a linear function? This one right here.
Not to the first power.
Because you have an x squared. We don't have a power. So that's the reason what's wrong with it. Okay, is this next one a linear one?
No.
It has x to the first power.
Yeah, but.
But this square root screws everything up. So no, it's not linear. What about this guy? It's x to the first power.
We're dying. We're dying.
It's what?
Dividing.
You're dividing by x. We're dying. We're dividing by x, so that's not a linear function. Okay. So all of those things are bad. So in order to be a linear function, linear over here. These are my requirements. Linear has to have an x and a y to the first power, and it cannot include not x squared, x to the third power, any higher powers than that. It cannot have a square root of an x. It cannot have an absolute value of an x. It cannot have a number that's over x. It cannot have x times y. Like together, both of those. It cannot have any of those things. It's just x and y separate to the first power, whatever. Okay? You cannot have any of those other things. Those are not linear functions. Okay? Good? Otherwise, they will graph certain things that are not correct.
Lost, but yes.
All right, so let's go down to A. Is he linear?
Yes.
How do you know?
Because you can get the y by itself.
You can get the y by itself, right? It's like a linear function that we're used to saying. He's x to the first power, y to the first power. I could solve for y if I wanted to. And I can make him in the form of y equals mx plus b, and everything is all ready to go. So yes, he is a linear function. What about B?
No.
No, why not?
Because no. Because we're dying.
Now, here's the deal. Put that away. Here's the deal. Just because it does not have a y, and they call it f of x just means y. So this is not a linear function because it doesn't have a y, because it technically does have a y. They're just calling it f of x. So that's not the reason why it's not a linear function. Why is it not a linear function?
Because we're dividing.
We're dividing by x. So on this and on your homework assignment, when it says write yes or no and then explain, all the kids were like, how do I explain? How do I explain? Okay, your explanation is going to be
No.
circle the part that's bad.
Bad.
Okay? So I'm going to circle the x on the bottom because that's what makes it not a linear function. Okay? That's a good enough explanation for me. All right, C, is he a linear function?
No.
No, why not?
X, Y.
X and y together. Okay, that's what makes it bad. Now, Jake Hodson this morning tried to pass this off. He said, well, you can just divide by y and then it's fine, right? Okay, so if I divide by y and divide by y and divide by y, I have to divide by y on everything, right?
Mm-hmm.
What's y divided by y? What does that reduce to or become? 1. So I have 1 equals 3x. It's looking good so far.
Well, you have the.
Until I have minus 4 over y, right? And we said that's not linear for the same reason that this one's not linear, because the x is in the bottom. Here the y is in the bottom, so I can't have that, right? So not a linear function, and we're going to circle the xy because that's why it's bad. Yeah, not linear. If it has any square roots, any thing like that, that is not a linear function. Okay? Good?
Good.
All right, now let's talk about these guys. Here's graphs. Here are 2 options. We have model A and we have model B, and they want to know whether or not this is a linear function. Okay? So model A, these are 2 different things, right? This table is not the same as the graph. They're not graphing the same thing. So model A
Yeah.
here, is that linear?
Yeah, they are.
Yeah, they are.
They're graphing the same thing.
No, they're not.
No.
They're graphing the same thing but with different numbers. So like model A is not a graph of what B is.
No, it's not.
No, because like 3 is at 1
Like,
or 2 is at 150. Right? This is not at 150 on 2. Okay? So they're slightly different graphs from one another. Is this a linear function? Model A.
Yes.
No.
What? No, why not?
It's not straight.
It's not a straight line. Okay. So Chase asked me this one. How do you know that it's not a straight line? It kind of looks straight. Okay. So I have a really fun pen that will allow me to do this. So I'm going to put a dot here, and when I put a dot there and I draw a line, it will let me draw a straight line. So I am drawing a straight line and I am connecting those first 2 dots. Do you see that? I'm going exactly through that second dot. Release my pen. If this was a straight line and it followed those first 2 dots and it intersected those first 2 dots, that's what that straight line would be. Okay, but it is curving slightly upwards, so this is not a linear function. Okay, so what's happening? Well, let's go over to the table. So this is not linear.
Hey, bud.
Not linear. What do you want?
Can I start helping you decorate for homecoming?
Right now?
Yeah, because I have.
Give me 5 minutes.
Okay.
Okay, you can sit tight. All right, model B. How do I tell from a table if this is a linear function or not?
Graph it.
Do
I
the.
don't want to graph it.
Go for Mark.
I don't wanna graph it.
It's not working.
Go for Mark.
Maybe I'll just say it in Spanish.
How do I know if this is linear or not? Shh. How do I know if it's
They're
linear?
all the
It is.
go down 25.
Go up 25. So from 100 to 125, you are adding 25, right? From 125 to 150, you're adding 25. Here you're adding 25.
every time.
Here you're adding 25. And because I'm adding the same number every time, it is
Linear.
linear. Yes, linear.
What did I tell
Because it increases by 25 each time. FYI, 25 is the slope. That's what it's going up by every time. Okay, over here, it's not quite going up by 25 every time. So from 100, that doesn't look like it's quite at 125. So we're going to say this one, it's going up by 20. Okay, from here to here, maybe it's going up by 25. From here to here, maybe it's going up by 30. Here to here, it's going up by 35, etc., right? So those are close to being the same number. That's why he resembles kind of a straight line, but it's not perfectly straight. Does that make sense? Okay, because not all those numbers are the same. I just made up those numbers, but that's kind of what's happening there. Okay, so no linear, yes linear. Okay. All right, identify symmetry. So now we're on the symmetry portion of it. We know how to determine whether it's a linear function or not. Now we're trying to see if it is linear or if it's symmetric. There are 2 types of symmetry. The first type is line symmetry, and the second one is point symmetry. Okay, so line symmetry. The easiest way I can explain this is when you were in elementary school, you probably did this project where you take a piece of paper and you fold it in half, right?
Mm-hmm.
Then you unfold it and you paint on one side and then you fold it in half again. What happens?
It comes out.
You peel it open and it's the same on both sides, right? It's like the mirror image. So that is a line of symmetry. The fold in your paper is the line of symmetry and it looks the same on both sides, okay? So in A, can I draw a line in the middle of that thing and it be the same on both sides?
Yes.
Yes.
Yeah. So I'm going to make my line right here. So the first thing we say, it asks, Does this have line symmetry?
Yes.
Yes. Line symmetry. Okay? And then they ask to identify the line of symmetry. So I need to write an equation for this line. What is the equation of that line? I'm going to make darker my x and y axis. So here's my x and y axis. Right here. 3 what?
3.
How do I write that line?
3x squared.
How do I write that line right there?
3x 0.
No, no.
3 0.
No.
That's the line called. What's the name of that line?
What line?
This line
0.
right here. This
What?
green, this blue one, or this purple one.
Oh.
3.
What's the name of that line? How do I name that line? What's the equation? What's the equation for that line?
Horizontal.
Something 3.
Latitude.
3.
3 latitude.
It's a horizontal. It's a
3
vertical
y.
line.
3 line.
Just 3.
3x, 3y.
3 vertical.
3 plus 2.
3y.
No, no.
Three
no.
vertical.
What is it called? What does it look like if it's a
I'm just
horizontal?
saying
If it's a vertical line?
3 vertical.
Chase, do you want to be brilliant? What is this thing called?
The y.
That purple line.
Oh.
What's the equation of that purple line? You people who are watching this.
Y equals.
No.
What?
X equals 3.
X equals 3.
I did it.
You people who are watching this video, are you screaming at the computer yet, saying, "You stupid people, why are you not getting this?"
I
X
did it
equals
wrong.
3.
We said
Okay,
that.
it's cutting through the x-axis. X equals 3.
Didn't we say
You
that
said
at the
3x squared, 3y
That was literally the
something.
first thing I
Yeah.
said.
Okay. X equals 3. That's the line right there. That line of symmetry is called x equals 3. Okay. Now B, can I draw a line through that in order for it to fold on top of itself?
No.
Now, if I draw the line this way, perpendicular to that line, right? He will fold on top of itself, except your line of symmetry has to either be a vertical line or a horizontal line.
Okay.
So, is there a vertical line that I can draw?
No.
Like, let's say I draw it here. Don't do this. This guy on the left side, if I fold him over, he will be like this, right? This guy right here, if I fold him over, he will look like this, yeah?
Well, who
Or
said
something
I
like
have
that.
to Fold it on that one.
You have to fold, well, you can fold it anywhere else you want to, but is it going to make a difference?
Yeah, you can fold it at an angle.
No, I said you can't fold it at an angle. That's a requirement. You can only have a horizontal line or a vertical line. So even if I do a horizontal line, like let's say I make this horizontal line and I fold it top to bottom, like I fold this guy down to here,
Teachers, please dismiss the junior high football players.
will that be the same?
Wait, what
Will
if
it
you
live on
fold
top of itself?
No.
No, not going to happen. So this is no line of symmetry. No line symmetry. Okay, no line symmetry. All right, let's go down here. This is called point symmetry. This is often called in geometry, this is called rotational symmetry. Rotational symmetry. So what I'm going to do is I'm going to rotate this thing and try to see if it is the same as what it was before. Okay, so this guy right here, A, if I take him and rotate him somehow, some way, is there a way that he will look exactly the same if I rotate him?
Yeah.
Okay, so I'm going to take your paper, rotate it, and flip your paper upside down. Does your shape look exactly the same as my shape?
Yes.
Yes, right? Okay, now where is the center of rotation?
0, 0.
The center of rotation has to be this guy right here. Otherwise, if you rotate him, he will not look the same. Okay? If I rotate him at another spot, he will not look the same. Like, let's say I rotate him here. If this is my center of rotation and I take this guy and I rotate him over here, he will look like this on this side, right? So the center of rotation has to be this point right here, which is 0, 0. Otherwise, when I rotate him, he will not be the same. Does that make sense?
Mm-hmm.
So the things that it asks, let's go over what it asked. State whether the graph of the function has point symmetry. Yes, point symmetry. Okay? And if so, identify the point or points of symmetry.
0, 0.
0, 0 is my center or my point of symmetry. Does that make sense? Okay, B. If I take him and I plot a point on there, can I spin him around somehow, some way so that he will look the same?
No.
No, because even if I take and put my point right here and I spin him upside down, then he will be a V that faces the other direction, right? Okay, now we said this morning, what if he was a perfect X?
Then yes.
No. Yes.
Okay? Then can I choose that as my point of symmetry and spin him around? Will he be the same? Yes. Yes, he will be. Okay? But if it's just a V, no, it's not. So no point symmetry. Does that make sense? Jake Hodson had the worst time with these. He's like, I can't see it. It's hard. It's hard to see these sometimes, especially if you're like one of those people who are really good at math and do the X's and Y's all correct and can add and subtract really good. It's hard for you to see pictures and see them moving around. So imagine like spinning this around in your brain, or physically take your paper and spin it around. That's fine. You can do that too. Okay. So there you go. Questions about that? Point symmetry, line symmetry. This is not too bad of an assignment, I don't think. Good. On the homework assignment, you guys had. Let me explain to you this. Practice, I said to do the odds for you people who are watching this video. Practice, I said to do the odds. Number 11, I did not realize, doesn't have a graph. So you can skip number 11 when I told you to do the odds, because there's no graph associated with that. Okay? Kyle, who's not watching this video, is not going to know that, so don't tell him that. Make him do number 11. All right? Everybody say bye.
Bye.